Good morning. It's November 27th, and this is your daily brief in science. Here's everything you need to know. NASA's recent radar imaging has unveiled the hidden remains of Camp Century, a Cold War military base buried beneath the Greenland ice sheet. This base was part of Project Iceworm, which aimed to create nuclear missile tunnels. Abandoned in 1967, Camp Century is now covered by approximately 70 feet of snow and ice, which includes around 47,000 gallons of nuclear waste, complicating future assessments of the site. Cryospheric scientist Chad Green noted that the new radar data revealed individual structures of the facility, although interpreting these images can be complex due to radar distortions. The UAVSAR images provided detailed insights into the condition of the camp after nearly 60 years under ice, showcasing its structures for the first time. NASA plans to utilize the data collected from these surveys to inform future studies of Earth's ice sheets, highlighting the significance of understanding ice thickness in relation to climate change. A 2019 study indicated that Greenland's ice melting has accelerated significantly, raising alarms about future ecological consequences and implications for sea level rise. The evolution of interest in Camp Century reflects a shift from Cold War military objectives to contemporary climate research efforts in the Arctic region. The base featured a network of 21 tunnels totaling approximately 3,000 meters in length, along with significant amounts of construction debris and hazardous materials. Constructed in harsh Arctic conditions, Camp Century could host 200 soldiers and included amenities such as dormitories, a kitchen, and a nuclear reactor. Although Project Iceworm and Camp Century were ultimately abandoned, the remnants serve as a historical reminder of Cold War tensions and the ongoing impacts of climate change. The radar imaging was conducted using NASA's Gulfstream 3 jet equipped with UAVSAR technology, which was initially intended for mapping ice layers. NASA scientist Alex Gardner remarked that the team did not initially recognize the significance of their findings until they analyzed the data. A recent study from the University of Oxford has revealed the remarkable seed dispersal mechanism of the squirting cucumber, known scientifically as Ecballium elaterium. Published in the Proceedings of the National Academy of Sciences on November 25, 2024, this research highlights how this plant ejects its seeds explosively. Using advanced imaging techniques, the research team employed high-speed videography, capturing the seed ejection process at an astonishing 8,600 frames per second. This rapid event occurs within a mere 30 milliseconds, showcasing the plant's ability to disperse seeds with a high-pressure jet of mucilage that reaches speeds of approximately 20 meters per second and can project seeds up to 10 meters away. Mathematical modeling conducted by the researchers indicated that the squirting cucumber's method of seed projection is nearly optimal, effectively balancing speed and range for maximum seed distribution. This evolutionary strategy allows the plant to spread its seeds widely, which is essential for reducing competition and enhancing the survival rates of its offspring. The timing of seed release plays a crucial role in determining their speed and launch angle. The first seeds are propelled further due to higher internal pressure, while subsequent seeds land closer, creating a broad distribution pattern. Notably, before the ejection, the stem of the plant undergoes structural changes, becoming longer and stiffer, which is vital for the successful launch of the seeds. The study also suggests that alterations in the fluid redistribution process could adversely impact seed survival and distribution. Insights gained from this research could pave the way for bioengineering advancements, particularly in the development of controlled drug delivery systems. Co-author Chris Thorogood emphasized the importance of understanding this botanical phenomenon, which has intrigued scientists since ancient times. The squirting cucumber has been documented since antiquity, with Pliny the Elder noting its seed ejection and warning of potential dangers. This research ultimately challenges the perception of plants as passive organisms, revealing their remarkable capabilities. Burkhard Militzer, a planetary scientist from the University of California, Berkeley, has unveiled groundbreaking research that transforms our understanding of Uranus. His findings, published in the Proceedings of the National Academy of Sciences, reveal a complex internal structure beneath the planet's thick atmosphere. Militzer's research identifies an 8,000-kilometer thick water-rich layer beneath Uranus's atmosphere, followed by a carbon-rich layer and a rocky core comparable in size to Mercury. This deep ocean of water is succeeded by a compressed fluid rich in carbon, nitrogen, and hydrogen, suggesting a more intricate composition than previously thought. Previous theories about Uranus and Neptune proposed non-mixing layers, but they failed to adequately explain the planet's compositions. Militzer's simulations clarify these issues, challenging prevailing theories like diamond rain and superionic water by asserting that the separation of layers is sufficient to explain the unique magnetic fields of these planets. The absence of a dipole magnetic field in Uranus and Neptune, as discovered by the Voyager 2 mission, supports Militzer's idea of immiscible layers. His computer simulations indicate that under extreme temperatures and pressures, substances like water, methane, and ammonia separate into two immiscible layers, similar to oil and water. Militzer plans to conduct laboratory experiments to validate his findings and expresses hope that a proposed NASA mission to Uranus could confirm the existence of these layers through planetary vibrations. His advanced machine learning techniques revealed that a water-rich layer forms above a carbon-rich layer under high pressure and temperature, providing insight into the chaotic magnetic fields observed. Interestingly, while Neptune is more massive, it has a smaller diameter and thinner atmosphere, yet is predicted to have a similar internal structure to Uranus, with a rocky core about the size of Mars. The research also hints at the intriguing possibility of diamond rain occurring on both Uranus and Neptune, adding yet another layer of complexity to their interiors. Recent research has uncovered alarming health risks tied to irregular sleep routines, even for those who believe they are getting enough rest. A study led by Jean-Philippe Chaput at the Children's Hospital of Eastern Ontario Research Institute analyzed data from 72,269 participants aged 40 to 79 from the UK Biobank, focusing on their sleep regularity over a week using activity trackers. The findings reveal that individuals who maintain inconsistent sleep patterns face increased risks of major cardiovascular events, such as heart disease and stroke, regardless of getting the recommended 7 to 9 hours of sleep per night. Specifically, those with moderately regular sleep schedules were found to be 8% more likely to encounter similar health issues. Participants were categorized based on their sleep regularity index, SRI scores, with scores above 87 indicating regular sleep patterns and scores below 72 indicating irregularity. While 61% of regular sleepers met the recommended sleep duration, only 48% of those with irregular patterns achieved the same. Experts emphasize that while occasional variations in sleep may not be harmful, chronic irregularity poses serious health concerns. To mitigate these risks, maintaining a consistent sleep schedule, ideally waking up and going to bed within 30 minutes of the same time each day, is recommended. Although the study is observational and cannot establish causation, it supports previous research linking poor sleep to increased inflammation associated with heart disease. However, limitations exist, including potential biases in the UK Biobank sample and the short duration of sleep data collection, which may affect the findings. These results underscore the importance of sleep regularity as a critical factor in cardiovascular health. A groundbreaking study published in Nature Cell Biology on November 27, 2024, reveals new insights into early neural development and its implications for neurodevelopmental disorders. The research, titled The Enhancer Module of Integrator Controls Cell Identity and Early Neural Fate Commitment, focuses on a molecular bridge complex that enhances our understanding of how neural cells develop, which is critical for addressing various neurodevelopmental syndromes. Led by Dr. Alessandro Gardini and his team at the Wistar Institute, the study emphasizes the importance of understanding the early stages of nervous system development for the diagnosis and treatment of neurodevelopmental disorders. A key protein identified in the research, INST10, is found to be more abundant in neural cells and plays a crucial role in maintaining neuronal identity throughout development, with potential links to integrator protein mutations. Through single-cell analysis, the research demonstrated that reduced levels of INST10 result in the loss of key neuronal genes and a shift towards characteristics typical of mesenchymal cells. This finding confirms INST10's essential role in sustaining neuronal identity. The study also investigates how pluripotent stem cells commit to becoming neural cells during neurogenesis, transitioning from a state of pluripotency to specialized types influenced by various biological signals. Dr. Gardini pointed out that neural cell development is influenced by more than just transcription factors, highlighting the significance of specific molecular signals in this process. He noted that this understanding of early neural development could help assess the causes and potential solutions for neurodevelopmental disorders, moving beyond traditional views. The research was funded by multiple National Institutes of Health grants and the G. Harold and Layla Y. Mathers Charitable Foundation. The findings contribute to a deeper comprehension of the fundamental processes in early neural development, which is essential for addressing neurodevelopmental syndromes. Ultimately, the study concludes that INST10 is vital for maintaining the identity of neural cells during their development and throughout their lifespan. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.